Okay, hi guys. So we'll be continuing on seeing some more examples of ring expansion. Okay, so let's start with some more examples. We have something like this. Presence of H plus, again we heat it. So what do we get? Again this one. Ring expansion. Positive charge here and two substituents here. What do we get after this? CH3 minus shift. What do we get after this? We get something like this, and positive charge comes here. Then HSF1 minus will attack on the alpha hydrogen here, and we'll get this as our major product. Okay, let's look at another example. Here we have something like this. And OH present here. Presence of H plus, we heat it. What will happen? We will get something like positive charge comes here. This is the intermediate. Now what will happen is this bond will shift here to have a ring expansion, and a cyclohexane will be formed here. Okay, again the positive charge will come. On which carbon? What actually happened is if we talk about this bond, so this bond actually broke up. Okay, and this bond actually I'm talking about, let me different pen, use a different pen. This bond actually broke up, and this actually got a negative charge, and here we got a positive charge. Okay, and this carbon atom comes over here. This to form a positive charge here and negative charge here, and this positive charge carbon atom comes over here, and this negative charge actually forms a bond with this positively charged carbon atom. Okay, so positive charge comes here. Now what will happen is we'll again have a ring expansion here, in which this 5-member ring will form a bond with this carbon atom to form a 6-member ring. Okay, so next what will happen is positive charge will come on this carbon atom. How? And we will get something like this structure. Okay, and we will get something like positive charge on this carbon atom. Not this carbon atom, actually this carbon atom will have a negative charge after breaking, and this will have positive charge. Okay, and this carbon atom actually comes over here to have a positive charge. Okay, now next what will happen is, in presence of HSO4, when we heat it, the double bond will be formed between the common carbon atoms. This will be the product of this reactant substrate. Okay, what about this case? We have something like this, and this here, and we react it with again H plus in presence of, and we heat it. Okay, so what will happen is, we will have a positive charge here, two double bonds here and a cyclopentane ring attached. Conjugation will take place. We'll get something like this, positive charge here and a ring here. What will happen again is ring expansion will happen, in which this carbon atom will get negative charge, this carbon atom will get positive charge, and we'll have a positive charge on this carbon atom after the ring formation. So we will have something like, again, positive charge here. Oh sorry, I drew the wrong structure. We will have something like this, and a positive charge on this carbon atom with two double bonds already here. Next, what will happen is, when we actually have HSO4 in the presence of heat, benzene formation, this will be the alpha hydrogen, and benzene ring would be formed with this fused cyclohexane ring. Okay, now actually look at the next example, and we will have something like this. And double bonds here and CH2OH here. What happens in again presence of H plus, and when we heat it, what will be the compound formed here? If we look at this, we will get something like positive charge here. Okay, and now what will happen is, so after this, what are all the possible options for this this compound to further stabilize the intermediate in RDS? We can have a H minus shift here, okay, which will result in something like this. Positive charge comes here, and CS3 forms here, and with two double bonds here. Now what will happen is, again resonating structures will happen with positive charge here. Again, what will happen is, positive charge here, okay. Now again, I hope you can relate to the previous examples, and this is the alpha hydrogen again here. This will form a carbon ion at this position, then it will form a benzene ring and a CS3 attached, which is called toluene. Okay, now let's look at another example. We have something like this. Okay, what will happen here? We will get carbocation at this position. Okay, now what will happen is, so we will get something like we can actually get negative charge on this carbon atom and positive charge on this carbon atom to form a cyclohexane, and in that cyclohexane, what we will be getting? something like this. Okay, you'll get a positive charge here and a ring expansion happens here. And let's suppose this was the first carbon atom. Let's name it 1. So this would be 1, this would be 2, this is 2, and this is not the naming convention, I'm just representing the or numbering the carbon atom. And this was the third carbon atom, and this is the third carbon atom. So bond formation occurs between 1 and 3, and second carbon atom gets a positive charge. Okay, now what happens is, again you know the procedure afterwards, that again HSO4 minus comes into the picture in the presence of heat. We'll take this hydrogen atom to form again a benzene structure. Okay, let's look at the last example in this video lecture. We will have something like, let's suppose we have something like this. So what happens, or what is the end product for this substrate when we actually pass it on in acidic medium and we heat that? So what actually happens is, we'll get something like this product, positive charge, positive charge here, and let's for now consider this case. So we would have negative charge here, this bond will be broken. So let's number the carbon atoms, 1, 2 and 3. So what will happen is, we will get a bond between 1 and 3, will form a cyclopentane, and between 1 and 3 we get a bond. And will this product be feasible after we actually expand this? Okay, so better let's look at the simple example first, where we have something like this. In which the actual product formation actually takes place. Okay, so between 1 and 3 we form a bond on the second carbon atom. So the second carbon atom, we get a positive charge here on the second carbon atom, and on the first, as it is, we have OH group attached here. Okay, so now what actually happens here is, again we get in presence of HSO4 minus, if we heat it, this is the alpha hydrogen here. Okay, so what will happen is, we'll get something like this, and we'll get OH here again in the presence of H plus, and we heat it. What will happen is, we'll get a positive charge here. And we already know that when we actually get this product in presence of H plus gets to benzene. So in presence of H plus and delta, we will get a benzene ring. Okay, as seen in the fifth example. Okay, so with this we come to an end of this lecture. In the next lecture we will be discussing dienone phenol rearrangement. Okay.